The surface area of a 3D shape is the sum of all the areas of all the faces that make up the shape. And a face is one of the flat or curved surfaces that make up a 3D shape. For example, in this shape, all of the faces are flat, but just like this rectangle right here would be a face, this square right here could be a face, and this one too, and all the ones that are like behind. And sometimes it helps to consider a 3D shape in the form of a 2D net, which is what I've done here. You can take this rectangular prism and then take everything, like all the pieces, all the faces, and then make a net. So this one would be like the one behind here. This one would be this square. This one would be the square right here. This is the face at the bottom. This is the side. And this is the top. So yeah, you just decompose it into a net or unfold it. And to find the surface area of cuboids, pyramids, and prisms, all of their faces are just polygons that are all flat. So what you can do is you just find the areas of each of the faces, just simple math, and then draw a 2D net maybe, and then you can just add them all up. Like for this one, assuming you have all the side lengths or edge lengths, then you can just calculate all of the faces and then add them all up. Now let's talk about some other shapes. First, let's do the cylinder, and its surface area is given in the formula A equals 2 pi r h plus 2 pi r squared. And you will need to remember this one, but it's pretty easy to figure out because if you unfold a cylinder and you draw the net, you have the two circles, which is given by pi r squared times 2. And then you have the rectangle, and the rectangle is kind of hard to figure out, but if you think about it, the rectangle goes all the way around the cylinder, and the length of the rectangle is equal to the circumference of the circle. So like this is the height, and this is the circumference of the circle, and the circumference of a circle is 2 pi r, and then you just multiply that by the height, which is h. So you have this for the rectangle and this for the two circles, and that's pretty easy formula to figure out. And for a cone, its surface area is given by A equals pi rl plus pi r squared, and the pi rl is this curved surface area that goes around the cone, and the pi r squared is the circle at the very end. And pi r squared is self-explanatory. Pi r l, the L is actually the slant height, which is not the height of the cone, but the side here. If you look at it from the side, it creates this kind of triangle. And if you're not given the slant height, but you're given the height and the radius, you can calculate the slant height by creating like a right triangle with the height, radius, and the slant height as the hypotenuse and using the Pythagorean theorem. And after you find that, you can just plug everything in and you get the surface area for a cone. And for a sphere, its surface area is given by the formula A equals 4 times pi r squared, where r is the radius of the sphere. So you only need one variable or missing value for the surface area. And if you're doing IB, then this formula is given in the formula booklet, so you do not have to memorize this one. But it's pretty easy to memorize. And now, let's get into some practice problems. If you think you can do this one, pause the video and try it. In this problem, and for all the next problems that I'm going to show, we're given this right pyramid, and this part asks us to find distance Vn. And Vn is this slant line right here, and it actually makes a triangle with lines Vm and Mn, so we can draw that first. This is point V, M, and N, and we can set distance Vn as a variable x. We're given Vm, which is 8.2, and Mn is, so M is at the midpoint between A and B at the center of the circle, so that means Mn will be half of 3.6, which is 1.8. And now using the Pythagorean theorem, we can write x squared equals 8 squared, 8.2 squared, plus 1.8 squared, or x squared equals 70.48, or x is approximately 8.40 rounded to 3 sig figs centimeters. And that's our final answer for this problem. And now, let's do another practice problem. If you think you can do this one, then pause the video and try it. In this problem, we're given the same right pyramid, and we're asked to calculate the area of the triangle ABV. And triangle ABV, we can draw that first. So A, B, V. And this triangle is just going to be this face of the pyramid at the front. And we're already given the base, 3.6. And all we need is the height. And the height is going to be the slant length from V to the bottom. And we already found that out in the last part. And the slant length for this side is going to be the same as the slant length for triangle BCV, because the vertex is directly above the center, making all of the triangles that are faces equivalent. And we found out our answer for the slant height, or the height for this triangle, is going to be 8.4. And we can use the area of a triangle formula to calculate all this. So 1/2 times 3.6 times 8.4. And if you do the math, it's approximately 15.1 centimeters squared, rounded to the nearest 3 sig figs. And that's our final answer for this problem. And now, let's do one last practice problem. If you think you can do this one, pause the video and try it. In this one, we're given the same right pyramid, and this time we're asked to calculate the entire surface area. So what we can do first to simplify this a little bit is draw the net, or like unfold the shape. And it's going to look something like this. Not exactly, but you have this square, which is the base, and you have 4 isosceles triangles, which are all the same. And we found out the areas of the triangles in the last part, because we found out the area of triangle ABV, which is 15.1. So first, let's write area equals 4 times 15.1, because there's 4 of them, and they're all the same because this is a right pyramid. And now we just need to figure out the area of the square for the base. And we're given one of the edge lengths, which is 3.6. And to figure out the area of the square entirely, we just square that. And now we have this equation, and we can just plug that into our calculators. And we're given approximately 73.4 centimeters squared, rounded to 3 sig figs. And that's our final answer. So everything that I explained in this video and all the problems that I went through should teach you everything you need to know about surface area of 3D shapes. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.